All right, guys, so I can see a lot of people joining us from various forums, so thank you very much. And as you're aware, we are going to talk about a very interesting topic, that is VoLTE, and to walk us through how VoLTE is vulnerable and also share with us the ways to mitigate and prevent and protect, rather fortify network against VoLTE. We have our expert, Pavel Novikov. Pavel is the telecom security research head with us at Security Gen, and he is going to walk us through this whole session. And we're going to start in about just a minute or two. But before we start, let me introduce myself. I'm Sonali. I'm going to be your host for the day, and I'm going to be there if you face any kind of an issue or glitch through the webinar. Now, a few things to remember here is quickly, I've unmuted all of you all so that you can get one way of communication, very clear and solid. The other thing, throughout the whole webinar, if you feel that there is any kind of technical glitch you're facing, or if there's any issue, do not hesitate. There's a chat window right at the bottom. Just hit me up and I'll try and resolve your query very soon. And in the instance that your chat window isn't working or isn't accessible, fret not. You can just show a raise of hand and I'll come to your rescue again. Now, coming to the whole process of this webinar, the way we have planned it, we are trying to consume about 45 minutes to walk through the whole presentation. And towards the end, about 15 to 20 minutes, we have part for Q&A. But we do understand that while going through the flow of the presentation and the slides, you may have questions. So I would request and recommend that start putting your questions in the Q&A chat box right at the bottom. We will try and address as many of those as we can through the process of the webinar. And the ones that are pending, we'll try and address those at the end of the webinar. And again, we have limited time, about 65 minutes today. So if some of the questions stay unanswered, you can always reach out to us at contact@SecGen, and I and Pavel would be more than happy to get those queries resolved. Lastly, before I move on and pass the baton to Pavel, our expert, I would like to say that this whole process and this webinar is getting recorded. And as soon as the webinar session gets over, we will share a copy with you for your reference, for you to share with your colleagues and discuss much on that. Well, this was a little introduction, but with this, I will not waste any more minute now and welcome Pavel to take over this session. Hi, Pavel, and welcome.
Hello, everyone. I'm Pavel Novikov. Today, I will present our recent research. So it's mostly not specifically research. It was our work and what we see and what's the reality related to VoLTE network. So first of all, who I am. So I am 10 years in telecom security already. So I'm a co-author of GSMA FS20 GPRS tunnel protocol security document of GSMA. So I head of telecom security research and delivery team in Security Gen. Focused on telecom vulnerabilities, not in some specific, but in whole telco infrastructure, radio access network, VoLTE, voice over Wi-Fi, GTP diameter, 5G, standalone and non-standalone, so and all other topics also related to security of telco infrastructure. So what I usually do, so I'm conducting telecom security assessment for mobile operators for many years already. So we have kind of experience. We have, so not only me, but we have several people who did this research and investigation. So me, Alex Onegov, who is not more our employee, and Sergey Mashukov, who probably doing some security assessment right now for some telecom operator. But before we start all this stuff related to VoLTE, you may raise question, why now? Why we talk about VoLTE and so on? Why not about, I don't know, 5G, voice over NAR, and so on? Before I can explain this, well, I'll provide some short course of mobile network evolution and highlight you and show you how it was built, why it's so. Because when you when you see something vulnerable or not vulnerable, or even that something working, it is better to understand history, how it was made, and then many questions may disappear just after this understanding. So first, so mobile network, how it was built. So first, there was 2G and voice-only network. I will not tell anything about 1G because it was analog connection. There was nothing modern, and well, we will not go deep in that. So as basic, we will take 2G because it's still there in most of countries. You can still find 2G network, and so it's kind of our legacy, and it's there. So what is that? So as you can see that 2G network, if you are talking about radio, so here's radio, base station, so some base station controller. Then there is some part which called socket switched core. And the main idea of 2G network was to deliver possibility to customers to organize voice calls, to remote voice calls, because previously you know that there was only the fixed line connection, and mobile network was appeared just to provide this possibility to make calls not only on some fixed place, but take your phone with you and make calls where you need it, not only in some fixed places. So there is some circuit switched core which allows to do that, and you see that it is connected to public switched telephone network. So it's just usual fixed line network. So when you connect to 2G network, and initially it was voice only, so you pass into public switched telephony network. As you know that the time of 2G it was 19th, and there was already some internet and data connections, and to get connection to the internet, most popular was like using usual modem, and the connection was very slow, but still it was there. And immediately when this possibility appeared to make these remote calls, when mobile network appears, so there was an idea, what if we can use it also for data connection? And immediately there was some expanding on 2G network to allow to do this connectivity the same like using modem, because still it is voice connection and it is possible. But if you look on mobile on 2G network, so it was specifically built for voice communication. It has frequency division and time division. So each frequency there are 8 time slots, and it is possible to deliver 8 up to 8 or 16 voice calls simultaneously. And it was specifically very well optimized for that. So just to do this voice calls, so it was fine for that. And the GSM network, it is a digital network, and voice, it is analog. So there was some specific encoding for that. So it was very well prepared for voice calls and very well optimized, because in those days there was not so much performance, not so much bandwidth, and so on. So just for calls. And when some people started trying to use it for data connection, they realized that connection is very slow. So it was like 2.4 kilobits per second, or the maximum was 9.6 kilobits per second. So it's very slow even for those days. And as a result, 3GPP and so industry, they made kind of extension of 2G network at data, specific data for 2G network. So it was done via specific dedicated core network. So your connection from phone passing to radio, base station controller, and then goes to this packet switched core, and after that it goes to the internet. The main improvement was here on the radio that for this connection, for GPRS, it is GPRS connection. For GPRS connection, you don't need, not you, but phone don't need to do this analog to digital and digital to analog transformation several times. So as GSM network already digital, we can use this possibility to transfer data directly without this encoding to analog, then to digital, then converse back, and so on. So it allowed to increase bandwidth. Due to some updates of this specification, so the best possible bandwidth was achieved something about 170 something kilobits. So it's quite, so it was quite good. It's better than dial-up, but it was already not 19s, but 2000s. So, and well, again, when this packet switched core and GPRS starts to introduce new possibilities to provide more bandwidth, so guys realize that, well, as basically as radio here on 2G network was specifically optimized to voice calls, probably it is not the best way to try to optimize it more, and it's already almost exhausted all the possibilities to optimize radio here to provide more bandwidth in 2G data. So they started to develop new generation of the network, and it brings us 3G network. So how it was made? So they added new radio, new base station, new radio controller, but all the rest was used from previous generation of the network. So circuit switched core and packet switched core, circuit switched core for voice calls, and connected to public telephone network, and packet switched core for the internet. They solved main issue on the radio of 2G network, because 2G network was totally not flexible to do these connections. But 3G network, they allocated, so it was not like in 2G network, so it is some bandwidth, about 5 megahertz usually, not usually, but it's the only option. So 5 megahertz of bandwidth, and you can take this bandwidth flexibly, so you can use it for voice calls, for data. So it made it possible to do this that data connection much faster. So there was a possibility to pass something about 10 megabit or even more. If you try to use internet on your phone right now, even in LTE, you can see sometimes it may be even less than 10 megabits, and we can say that it is quite enough for usual subscriber to use it. But there is a problem, because when they developed this 3G network, it was quite okay when you tested in labs and so on, in Faraday cage, on some, I don't know, premises. But when it was deployed in real life, so in some places you can there are a lot of people, and the problem is that this bandwidth is not for single person, but this bandwidth is for all of people here. So that's why industry realized that this 10 megabits or even more, it is not enough to provide enough bandwidth to each subscriber. So it is needed to increase it somehow, to make this possibility to to provide enough bandwidth to each subscriber. So that's why they realized that, well, 3G network is quite good for data, but not for many people. So that's why we need to build new one. And they added 4G. So they invented 4G network. So as you can see, 4G network is not connected to. So this infrastructure was made for 2G and 3G network. For 4G network, it was total update. So it was now base station becomes InnodeB, and they made a VoLTE packet core. So it is new core for LTE connection. So to go to the internet via LTE, you use totally different connection, totally different infrastructure in mobile network, and you will go to the internet. But looking on this picture, you may recognize that something wrong here, because where is voice connection? That's a good question, because as you can see in this architecture, there is no connection to public switch telephony network. So it looks like you can't call anymore so you can't use your phone for calls. And it's basically almost true, because the reason why 4G network was made is just to provide more bandwidth to the subscribers. And I would not say that they forget about voice, but it was not like priority, because voice, it was a case in the 2G. So for voice, there was no issues at all. So 2G you can use for that and so on. So, but still, this is mobile network. We should pass voice somehow. And natively, so for 4G network, native voice should be implemented via dedicated IMS infrastructure. So IMS infrastructure, it's IP Multimedia Subsystem, and it is C protocol based. So yeah, so there should be some specific infrastructure built for that, and it's like IP phone. So like LTE network started widely used in 2010 or something like that, and it's already Skype was popular for those times and so on. So it's like IP telephony here. But as you see, that the problem is that something else should be deployed here, and to not do that, there was kind of workaround how to do that. And this technology called VoLTE. I forgot to say that. So that's what we are talking about. But for those operators who are not able to build this IMS infrastructure, so they have nothing here. So they invented some workaround, so which called CS fallback. So when subscriber connected to LTE network, so he registered to MME in a VoLTE packet core and simultaneously registered in circuit switched core in MSC. So, and when you try to make call in LTE network, your phone immediately goes to 3G network or even 2G network, and your voice calls going over previous generation. So that's how it was solved. So because when LTE deployment started, so the main idea was to deliver more bandwidth for packet data, but for voice, they still can use all these old generations, and it looks kind of good idea for those time. Let's briefly explain how it should work in 5G. So there are two different 5G technologies, 5G non-standalone, and it's shown here. For 5G non-standalone, basically it is usual 4G network with 4G core, with 4G infrastructure, and the only difference that there is also 5G radio and it's connected to 4G radio to the inode B like slave. So when subscriber, I know, it's connected to the network in standby mode, so it's almost all the time using 4G network. If subscriber trying to reach some, for example, YouTube and download a lot of data, so there is second link. It is not switched to 5G, but it is second link, and user data passing through the 5G network and going to the 4G core. As you can see, that it's like something on the radio, but not more. So all the rest is the same. So here again, VoLTE for voice calls, or yeah, it's VoLTE. If we are talking about 5G standalone, so for 5G standalone, there is again a new radio, new base station, new infrastructure. But the idea is quite similar to the LTE. So we have connection to the internet and we have connection to the IMS infrastructure. We still can use previously built IMS infrastructure, which was built for LTE. The only thing that you need some updates and so on just to support this communication between IMS infrastructure and new signaling networks via HTTP2. So, but basically it is the same and it is similar. And now it's called voice over NAR. I'm not sure that you will see this on your phones, because as we see that depending on vendor, you still can see VoLTE and so on. Even if you use 5G standalone, there could be little VoLTE, because basically it's the same technology, the same idea, so it is totally the same. That's why when we are talking about VoLTE vulnerabilities, it's totally fits to 5G or any of 5G infrastructure, even standalone or non-standalone. So it is the same. Even it have different name, but the idea is totally the same. And for 5G, still this trick with fallback still working. So in non-standalone mode, you can still switch to 2G or 3G network when you make voice calls and so on. And well, yeah. The thing is that I realized that many people surprised that on some networks there is no voice calls over LTE, because when they starting to call, so they open their phone, take it, and they don't see that your phone switched to 2G network or 3G network. That's why many people even doesn't know about that. So yeah, it's the thing. If we dig into the history, so we can see that first LTE network deployment was in December of 2009, and it was Telia Sonera, and it was Sweden and Norway. So just remember this December 2009 year. So first VoLTE network support was introduced only in August 2012 in USA, and there was first phone which was supporting voice calls over LTE connection using IMS infrastructure, so VoLTE. So the only phone was LG Connect 4G. So you see that LTE network was already in deployment since 2009, but almost 2.5 years there was no IMS infrastructure at all in the world. So since this time they started to even not to use, but try to use it, but it is not so simple. But full-featured VoLTE network was appeared only in May 2014 in Singapore, and again with only one phone, Samsung Galaxy Note 3. And almost all new phones having VoLTE support only in 2020. So only in 2020, all the phones are starting to support VoLTE connection. So it's very strange. I mean, not very strange, but it's surprising that 10 years after LTE network was deployed initially, so only after 10 years after that, all the phones in market. So if you go into the shop and buy a phone, you can be sure that it supports VoLTE. So it started only in 2020. You know that 5G network was introduced, so some specification and some first deployment was happened in 2018. So 5G network was already under deployment. I mean, specification was prepared. Some phones started to support 5G, but still there was no full support of VoLTE, so voice over LTE. So that means that you can't forget about 2G and 3G networks. They should be in use just to provide this basic feature of mobile network. It's voice calls. And after 2020, when all the phones started to support VoLTE network, so some operators started to think, well, it seems time to deploy VoLTE. So basically, telco industry is very slow. Sometimes it's very fast. I mean, they're trying to deploy this 5G and so on, but regarding some other things, it's very slow. And VoLTE is really unlucky technology because no one was caring about it for 10 years. But some bombshell happened. So Verizon USA, they wrote that they will retire the 3G and 3G and 2G network by the end of 2022. So you can think, okay, Verizon can do whatever they want. It's their country and so on. But it's not so easy. Initially, they told that they will retire this 2G and 3G network in 2019, but they postponed it. You remember that only in 2020 all the phones started to support VoLTE. So that's why many other so they haven't believed that in the end of 2022 they will do that and they will retire the 2G and 3G network. But what does it mean? They will retire this 2G and 3G network. It means that this piece of the infrastructure will be totally decommissioned, and so just this part will evolve packet core and 5G will be there, and only IMS infrastructure there. So there is no way now to use circuit switched network, public switched telecom network. So the only way to use it's IMS, and it means that if subscriber move to this country and connects to this network, so if home network do not have this VoLTE possibility, so subscriber will not be able to call. I mean, let's take another country, another operator, whatever will be there, and so just subscriber of some operator of some country go into USA, and they can't call because there is no VoLTE in his home network. But in USA there is no circuit switched calls. So after that, it was not possible to make calls anymore if you are in roaming there. And money and reputation of such operators were affected in the beginning of 2023. And then started some very interesting thing. It's I call it like build VoLTE network in 60 seconds. Well, it's not 60 seconds basically, but operators started to build their VoLTE network very fast. Many of operators built it in few months, and many configuration mistakes were made due to that because they were really in a hurry. So I'll take a pause here. If you have any questions, I see that there are some questions I will answer right now, and then, yeah, we will continue.
Hi, Pavel. Yes, there are a few questions you would want to address here now.
Okay, I see one question. Does it mean that shutdown of 2G network accelerated VoLTE deployment even for those who were not planning to do so? Exactly. This is exactly what happens. Many of operators, they were not really willing to update and to introduce their VoLTE infrastructure. But this shutdown of 2G network, even in some countries, which is not their countries, so this makes this acceleration, so they should do that. Okay, one other questions. Since we are hearing about 5G, but still progress in many countries seems to be slow. Do you think hype of 5G network is overrated? Well, hype of 5G network, it's something that started maybe, I don't know, in 2016. So there was a lot of 5G, 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 5G security, 5G infrastructure, 5G calls, 5G phones, and so on. But my personal view that yes, it's overrated, because yes, we still see that some operators still struggling with 5G deployment or even introduction of VoLTE and in their network. Another question: VoLTE security refers just to IMS infrastructure? Basically, yes, this is the main point. So VoLTE security mostly based on IMS infrastructure. So I mean, VoLTE based on IMS infrastructure. That's why security also based on IMS infrastructure. So how you build this IMS infrastructure, how secure you are, so depending on that. Is Verizon the only one in USA who switched off? No, it was not the only one. As I know, AT&T also switched it off. So that's kind of for whole country.
Hi, Pavel. In the interest of time, maybe we move to the next chapter and address the questions at the end.
Okay.
So we can cover everything.
Okay, yes, I'll continue about vulnerabilities and so on. Then, if we will have time, I will
We'll
answer.
go back to the question panel. Yes.
Okay. So now to understand the problems in IMS in VoLTE network, so first we need to understand IMS network, because it seems that it is basic for VoLTE. And yeah, you saw this picture before, and you see that at the edge of a VoLTE packet core there is something called PGW, and it have connection to the internet and to the IMS simultaneously. And the question is how to distinguish between these two connections, because it seems that some phones should be connected to both networks simultaneously, and how it's done in mobile network and mobile phone. So if you take some, well, let's say old phone, old style phone, some Android phone, maybe Android 6, 7, 8 or something like that. So you can see that there is a section APN, it's access point name. And in APN section, you can find Internet APN and IMS APN. Internet APN, so this is connection to the internet, and obviously IMS APN is connection to the IMS. Now we need to understand how to make phone to understand which of the APNs phone should use in which way. For example, if the connection is internet connection, so we need to use it as default route and send all the data to this route. But if we connect it to IMS APN, we need to route there only voice calls and so on. So and the way how it's done, so in configuration of access point name in APN, there is APN type, and APN type is IMS for such connection. So if you type IMS, that you make phone understand that phone should use this connection only for voice call. If you put here default, it means that phone should use it as default gateway for all the traffic for data and so on. Now, funny thing, it's security by obscurity. It's very usual for telco operators. So just to not people understand how it works, modern phones are hiding IMS APN from the list of APNs. So if you take phone with Android 10, 11, 13, 14, doesn't matter, you will never find IMS APN here because it's hidden. So even if you add new one and add IMS APN, you will push save, but it will disappear. So you will never see where it is. So they are hiding this APN. So that's why currently it is not possible to understand how it works from subscriber point of view. Okay, now we understand how it works from phone side. Let's try to understand how it works from operator side. So this is IMS network. After PGW of a VoLTE packet core, there is IMS subsystem. And as you can see, it consists of some number of different network elements. So P, CSCF, I, CSCF, S, CSCF. So this is the proxy, this is some other things. They connected to general database for authentication. And there is also some infrastructure to make it possible to call to the public phones and public infrastructure, and dedicated connection for IP phones, IP infrastructure, IP trunks, and so on. And it started there, and here started for circuit switched connection. So let's go to the topic. Finally, how to hijack VoLTE network. And the first thing, we need to break rules. So how to break rules? Okay, we need to add APN, which called IMS, but not use IMS as APN type, but default. In this case, we will let phone understand that this connection should be used for usual traffic, usual data, and when we get connected, so you're already in IMS infrastructure. It's very easy. You don't need to be a super hacker to do that. So, and even you can open install some application which called probably terminal emulator, and you can run even nmap on the phone. So as you can see, I don't have on this screenshot, I don't have nmap on the phone, but basically it is not a big problem. There are some source code, so you can build it for Android, or even you can find already built executable binary, so you can run nmap on your phone and scan IMS network for some vulnerabilities, like pen testers usually do for usual IT infrastructure. But I would say it is not very convenient way to do that from using phone. So you can, or anyone can use more common tools, and it's surprisingly easy. So you just need LTE dongle connected to laptop, configure APN as IMS, and take profits. So you will be connected to this IMS infrastructure like the usual IT network, and you can run nmap, whatever you want, any other tools, Metasploit, so whatever you want. So that's the way how get connection to this infrastructure. Now let's explain what we found initially when we connected to this infrastructure, what we found basically. So one point that if you connected to the internet, so you as subscriber, and for example, your friend as subscriber, you will not be able to reach each other via this connection because ETW has some configuration which isolate you from each other. So you only have connection to the internet, and your friend also have connection to the internet, but you can't communicate between each other. You can directly send any packets, IP packets between each other. But when we think about IMS interface and IMS APN, surprisingly, we found that in many operators, it is possible to do that. So even in some operator, there are isolation for internet, so you can't reach your friend via internet connection, but there is no isolation on the IMS connection. So with an IMS connection, you can send packets to other subscribers directly. It means that you can run Nmap, you can run whatever you want, any tools, or you can make some peer-to-peer communication using this IMS infrastructure. I can't say why it's so. We have some ideas, for example, IMS infrastructure based on SIP protocol, and SIP protocol can use some feature which called direct communication. So in some SIP implementation, you need this server only to establish call, but then your voice will pass directly between phones. Maybe due to this assumption, some people configure this PGW for IMS infrastructure without this isolation. But basically, it is not the case for VoLTE infrastructure because VoLTE infrastructure should act always via IMS infrastructure. So there is no need to do this direct connection between subscribers. So that's why it is misconfiguration. But okay, we found this misconfiguration. Let's think what we can do with that. So we connected our laptop and USB dongle. So we're using IMS APN. So we connected to IMS infrastructure, and we were able to do some communication between usual phone and this laptop. So what we can do after that? The idea was like maybe we can try to build our own fake IMS infrastructure and do some kind of, so we will, in this case, we will build our own IMS infrastructure, which is not related to operators infrastructure. So we started to think about that. Let's return to this scheme of IMS network infrastructure. So we had a look on that and realized that as we don't have public switched network, we cannot use it. Also, we don't need this equipment because we don't have this connection. Also, probably we don't have IP phones, we don't need it, and that's why we don't need this piece of infrastructure. And then we realized that basically we can build this PCSCF and ICSCF using Camaleon software. Then again, for purpose of authentication, we need somehow to request authentication key from HSS, from a real HSS. So that's why we need somehow to bypass it to real one. So we started in difficult way, but then we realized that we don't need all this stuff. We just need simple script here on our laptop, which will just bypass connection to real infrastructure, and we can get authentication keys from real network. So you see that now it is possible to do this way. So some subscriber can connect to our fake IMS, but it is not fully fake IMS. It's just fake PCSCF. And then we bypassing it to the real PCSCF, so to make it authentication work and so on. So, but we faced one problem that basically when subscriber connected to IMS infrastructure, this PCSCF address provided to the phone during connection procedure here from MME, but we don't have control on MME in this case. And we need somehow to push this to the phone. And the main question is how. We tried multiple options, tried multiple ways, but finally we just decided to hack the phone itself. So, for example, for for Samsung phone, you can download this application from Play Market, install it, and this application is just one button application which runs some menu of the phone. So it's IMS setting of the phones, and you can change, for example, PCSCF address or whatever you want. So you can play with IMS configuration here. So we tried, well, it was working for us, but depending on phone, depending on Android version, it may be not enough because in latest Android, there are not enough configuration here. And in this case, probably you need to root your phone and change some config files in the phone. For Qualcomm-based devices, you can edit MBM config. It's some specific partition of the phone, so you also can download it. There is some specific tools for that, but still, it is possible to do that. And as a result, we were able to do this. So we have reconfigured phone. We were able to make this MITM. It's almost well, it's successful MITM. So on the laptop, we can see all the data, all the calls. So even if some SMS or something else happens, so everything passes from this subscriber to us, and then we pass it to the real IMS infrastructure, and real IMS infrastructure is okay with the situation that we are in the middle of this connection. So it was working, but yes, the only problem that we can't hack any phone in the world using that. But we found simpler way how to hijack VoLTE network. So MITM, yes, it is possible, but there are some limitations. But what we can do with usual phone and how we can use this possibility. So we made this thing. So we connected this laptop to the internet, connected using USB dongle to the IMS infrastructure, connected phone to IMS infrastructure. We established OpenVPN server on our laptop, installed OpenVPN client on the phone, and we were able to connect. So our subscriber can connect directly to our laptop and get connection to the internet. That's the idea. And the thing is that internet APN have charging based on used amount of data, but for IMS network, charging based on minutes, and this is implemented into IMS infrastructure, so not in on data level. So, but when you set up some call, some nodes in IMS infrastructure starting to count that, and as a result, you get billing based on that. So based on number of minutes which you spend on the call. But as we don't use IMS infrastructure at all for data, so we just use this IMS connection like Cube. So this APN is not charged for data. And due to lack of the isolation, we can establish direct subscriber-to-subscriber communication. We can set up OpenVPN tunnel to another subscriber and use his internet, probably for free, most probably for free. Also, other kind of tunnels can also work, or you can establish even peer-to-peer network. So even you can run torrents or something like that. And if the network provides VoLTE roaming capability, then we can implement this free internet even being in roaming. So being in roaming, you can connect to this IMS connection, for example, to your laptop, which is you can leave at home and so on. And well, it will be for free. And now I have demo about that. Well, before I show the video, I just need to explain briefly. So I have a laptop. So on this video, what happens? I have a laptop. To the laptop connected USB dongle, Huawei dongle. We configure this IMS connection for APN. We have another phone which is basically connected to the laptop via USB cable, but just in the purpose of that, just to upload some file from laptop to the phone fast. And now I'll run the video. So we have this APN, so we configured it on the USB dongle. Then we can go to device information and see that we obtained this IP address, which is highlighted here. On the left side, I'm establishing OpenVPN server based on this script. We need to type this IP address which we obtained. So it's quite easy. I mean, you just need press default one, and so on. So this is how it happens. We can establish OpenVPN server. Installing. Yes, it's ready. And there is some certificate and the OpenVPN config for some default user. We just need to copy it, change privilege for that. Now I open phone. So this pass from phone, this pass or top one from laptop. So I'm transferring this OpenVPN config to the phone. Now I can close it. Now I need to reconfigure some settings in OpenVPN server because by default it takes wrong interface, but it's okay. We just need to change IP address, restart server. Now I'll switch off browser just to not show this data how I connected to the browser. So start Wireshark again, and then I'm taking phone. Creating a new APN. So the name is IMS, yes, finally. So we need to type APN name, it's also IMS. And now we need to write APN type, and it should be default. Okay, now we can save it. And now we need to switch and activate it. Okay, we activated it. Now I go to the web browser and try to search something. As you can see that IMS connection basically doesn't have any internet connection. So you can see that it is not working. Now I open OpenVPN client, install this OpenVPN config from laptop. And now you see that I was successful to establish this connection. I'm back online and I'm trying to reach some web page, which is some security conference. This web page it's quite heavy, so it's quite big one, but it's going quite smooth. Well, not split second, but several seconds, and all this heavy stuff is loaded. So I just bypassed all this stuff. This is the end of this video. So okay, I need to go next. So what happens? Basically happens what I already described. So initially I installed OpenVPNs. Initially I installed established this IMS connection via USB dongle, established OpenVPN server on the laptop. Then I passed configuration file to the phone, and then I was able to connect to my laptop via real network and get access to the internet. That was the main idea. So if you have any questions regarding to that, Okay, I'm ready to answer to them right now. So I'll open questions in Zoom. So first question, if 4G network is closed, is there still required IMS? Okay, if 4G network closed in terms to replace it by 5G, still you need IMS to provide voice over NR calls in 5G. How is operator view from security perspective in moving to diameter HTTP signaling as compared to SS7 security issues in 2G, 3G network? Well, this topic is not related to our webinar today, but I will answer briefly that well, usually operators right now, they are not doing it in this way like it was made for SSM, like SSM network works for many years, and then they started to interest what is about security of that. Diameter and HTTP2, we see that there are some demand from operators. They are interested in signaling and security of that, so it's working, but not all the operators in the world for sure. Now next question, why 5G standalone, why not an NSA approach? Operator are choosing where they already have infra, what are the reasons which force operators to go 5G standalone with new infra and new encryptions? So the question is why operator want to deploy 5G standalone? Basically because 5G standalone, it's real 5G. 5G non-standalone, it is not purely real 5G because in non-standalone mode, your phone just sometimes using 5G connection just to pass some big amount of data. All other time you connected over LTE, and even more, all the signaling and so on is going via LTE connection. So all the vulnerabilities related to LTE is applicable to this deployment for non-standalone. So basically, non-standalone, it's not real 5G and do not provide those possibilities like low latency and so on. Okay, there are a lot of other questions. I need to finish my presentation about mitigation. So I'll go to explanation of mitigation, what operators should do, and then I will return to questions if you have time. So, so the question how to protect VoLTE network. And well, when we raised this question how to hijack VoLTE network, we told like break rules. Now we need to protect VoLTE network, and now we need to follow rules. And these rules are quite simple. So first of all, you need to ensure that you have this isolation for subscribers because it's configuration issue, because it is not something impossible to do that because it's already done for internet connection, but it was not done for IMS infrastructure. So operator should block this subscriber to subscriber communication for IMS. Also, this PCSCF, it's proxy, and the main idea of using PCSCF is just exactly to hide whole IMS infrastructure from subscribers. So subscribers should see only this piece of the network. But we see that it is not basically true in most of cases. So we can see some packets which targeting some other nodes and so on. So some direct communication with other nodes. So I would say that this proxy configured not very well. And what we can recommend and implement correct implementation, correct configuration of this node, or even if it is not possible, for example, you use, I know, some vendor which doesn't have enough capabilities to mitigate that. So probably then you need some specific firewall which designed specifically for VoIP traffic, something like SBC, and you need to put it here somewhere, so something like that. Also, the biggest trouble of for mobile network that there is no any capabilities to watch. So what I did and what I showed on the previous on the video on the demo. So we are doing this stuff. So we stealing their network. I mean their resources to use this internet connection for direct-to-direct communication. But the main problem from operators is that they can't see it. In most of cases, they can't catch this suspicious activity because they don't have monitoring systems usually here. Sometimes they have somewhere, but again, to catch something, you need to understand what you need to find. Because if you don't understand, if you don't know what to find, if you don't understand what attacks are possible on your infrastructure, it is not possible to protect because you will not be able to see in right place in your network and to gather necessary information. And for one more important point, well, introduce just a small bit of security testing because when you deploy new technologies, new subsystem in the network, just to check what is about security of that, because as I told that many operators build it quite fast, very fast, and they don't care about security because they are caring about performance. So not performance, but just to make it work. So when you did it, just introduce one step of acceptance just to test it somehow, because otherwise you will even not know what happens in your network. And one more point, read some important security guidelines. So for example, in GSMA, there are two of them, FS22, it's VoLTE Security Analysis and Recommendation. It's quite old one. Well, there are some good points. Some points are quite theoretical, but still idea is okay. And there are other documents. It's very good one, FS38. It's quite new and a good one, but the only one problem that it is 235 pages. That's also the problem on the security, that if there are some good paper, it's very big and many people just not able to read it and even to understand that. That's also the problem. So as conclusion, we can say that such misconfiguration, so lack of subscriber resolution on IMS APN, we see in more than half of tested network. Mobile operators are a bit slow, many postponed deployment and so on. So they were not caring about VoLTE for 10 years, but now they push it to deploy it fast. And that's why we see that due to this hurry, they are not secure because they were not able to test it. And so bringing the minimum required level of security is not a difficult task, just similar to the idea 110, 100 rule. So the sooner you can catch the issue, the cheaper you can fix that. Because when your network already exploited, well, you already lost some money. So that's the end of my presentation. I see that we almost out of time. In case you need any help or guidance with security or anything related to mobile networks, you can contact us. Feel free to reach out us using this email. I'm not sure that we have time to answer questions, so please tell me if you can do that, or we will answer later in LinkedIn, for example.
Thanks, Pavel. Maybe we can overshot a few minutes and pick a few questions to do some justice here. If
Okay.
you can. Another 5 minutes or so.
Okay.
Yeah.
So, okay, I'll go just one by one. Sorry, I can't choose some specific one. I will just go one by one. So what is the benefit of hiding IMS APN on the mobile phone from security perspective? What's the point? That's a good question. The point is that mobile industry realized that Usual subscriber don't need to see it at all. So as he don't see it, probably he can't understand how it works and how to break it. Next question: the RM net interface is open on certain modem models. Basically, RM net interface is interface on your phone. You can see it, and even using some, if your phone is rooted, you can change some configuration, routing, and you will be able to send it. So it's open. Can we disable IMS APN on your MNP? Yeah, if you will turn it off, then you will block VoLTE possibility. So subscriber will not be able to call using LTE network. So basically, you can do that, but the idea is vice versa, to activate it just to allow modern technology to work. Do we need to root dongle also? No, we don't need it. So we don't need to do anything, just configure. What's the purpose of CoreMS app? So using this app, you can just run some specific menu of Samsung phone, which allows you to change IMS configuration. So that's the idea. Is this exploit facilitated by presence UE to UE communication for IMS full range? Yes, exactly. This exploit working due to this problem, because subscriber can reach other subscriber. Please tell us the name of some tools you have used. Do you use specific tools or write script name tools? The only tool is OpenVPN server, OpenVPN client server. You can establish it. Just find some manual in the internet how to install OpenVPN server, and that's it. So you don't need anything specific. If UE to UE communication is blocked, would this mitigate this exploit? Yes, it will mitigate specifically this exploit, but it doesn't say, I can't say that your network protected, because this is only like top of the iceberg. So it's not, so there are always some other problems in IMS infrastructure. For example, some weak encryption or even lack of encryption and so on. So still, you can fix this problem, but there are others. Does this way bypass authentication process, or do we can send something zip packet? This specific method do not bypass any authentication, but for sure we can send some zip packet to the network using just we just need to know IP address where to send.
Pavel, sorry I'm interjecting, but I guess we need to take a hard stop. I still see a few questions. So thank you to you, Pavel, for this entertaining and insightful session. And all the attendees, thank you very much for joining us today. And we are sorry we could not address all the questions, but time was of a limitation. But what we're going to do, as we promised at the beginning, we're going to have a recording of this session. We'll email it to you on your registered email ID. We will also again copy paste contact as section in your emails in our follow-up email. And if you feel there's one question or more that has been unanswered, please reach out to us and we'll try and resolve that for you. But otherwise, it was great meeting you here. Thank you for taking the time. And thank you for being a lovely audience. Take care, everyone.
Thank you all. Goodbye.
Thanks, Pavel. Bye, everyone.